Hi, good afternoon, everybody. If you could hear me and see the screen, say good afternoon in the chat to check in, and we are about to get started. All right, guys, today's topic is matrices and vectors, which is question 10. So we're going to take the first 15 minutes of class to just touch a little bit on the things that you should know, and we're going straight into the past papers, right? So I think we should start with vectors because vectors is pretty straightforward. There's only a little bit of diversity when it comes to the questions and the difficulty levels, but it tends to be, or it tends to follow a pattern when it comes to the questions every year. Matrices, though, there are elements of matrices that are actually complicated, which is matrix transformation. So I'm going to spend some time on this. Um, no problem, yeah. Yeah, so I'm gonna try to spend some time and give you guys some shortcut notes here to kind of assist with this topic, right? Yeah, so I am ready to go. So just a heads up, you're gonna definitely need your notebook or something to write in. You definitely need your calculators, pencils, and all that good stuff. All right, so if you guys are ready, say ready, and we're gonna get started once majority say ready. All right, something to keep note, right? Honestly, question 10 is one of those questions that you should be aiming to mash up. So when you look at the out of the 10 questions, you must have at least 5 to 6 questions that you definitely feel 100% confident in. And question 10 should be in that five. So I am hoping at the end of this session, we leave class today feeling like, okay, question 10 is not so bad. It's definitely manageable. I just need to know certain things. I need to do some practicing. All right, so let's start with vectors. First thing first, what we should know is a vector is a movement in a certain direction with a certain quantity. Vectors could be represented in three ways. So it could be represented as the capital letter arrow way, which gives us some information. And in this case, the information is that the vector is going from O, which is the origin, to point A, right? And in this case, that's a positive movement. Something that you should know as well is if you go from A to O, like here, that's a negative A movement. So if forward is positive, backwards is negative, okay? We have two types of vectors, but just to make sure we make note of the other two ways you represent a vector. So you could represent it using your capital letters like this. You could represent it using a common letter. So you see here we have small a, and you could represent it as a column matrix where X represents the left or right movement, Y represents the up and down movement. And something that you should know is when X is positive, just like on the number line, you're on the right hand side, you're moving to the right. If X is negative, that's a left movement. Similarly, if we have positive and positive Y is upwards, going up, and negative Y is coming down. All right. So we need to be able to understand a few things. Another thing that you should know is that there's two types of vectors that are extremely important. The first vector is a position vector, which starts at the origin. So that means the place where the vector starts is at point 0, 0, where x is 0, y is 0. And then you have a displacement vector. So for example, I'm going to use a red line to draw a displacement vector AB because it does not start from the origin. So quick question, everybody should be familiar with all of this information, right? Yes, no, talk to me quickly because you're going to hear these terminologies a lot. Position vectors, displacement vectors, positive movement, negative movement, right? All right. Another thing that you should know is a triangular law, because this is literally one of the most important things that you're going to use in the exam for this question. And how do we generate the triangular law? Something that you need to know is, for example, if I want AB, so let's look at this triangle. Let's pretend that this red line is not here. So there was no direct path to go from A to B. Where would I need to walk to get from A to B? Remember, we pretended that this line does not exist. So if I am at location A and I want to get to location B, I have to follow the pathway. What is the pathway that's available to us? I could go from A to O. Everybody say that? A, O. And then from O, because O is also connected to B, I could go OB. So that's why to go from A to B, I had to go AO plus OB. So one of the rules in the triangular law is that the middle terms must match. So we're going to do a quick activity to understand how to do this. So I have some examples here, and then I'm going to give you a few to do on your own. So we have some vectors available. Some are position and some are displacement. So the first thing I'm going to ask you is to label each. For position, you're going to type P. For displacement, you're going to type D. So the first one, P or D, is this a position vector or displacement, OA? Let's go, guys, quickly. And remember, you don't have to type up the whole word. You could just type P or D. So P is for position, D is for displacement, just for us to be able to go a little faster, right? Now, please note this. I cannot teach because of the timeline that we have until the exam. If you have not learned this yet, you're going to have to make some effort to learn this on your own. And that's if you're a teacher in school or if you go to an extra class. If your teacher have not covered this topic, you have to go and learn this on your own. And you could even message me for some notes. You could actually message me for videos. There are videos on YouTube, but these are things that you have to know already, right? And if you don't, it's not a lost cause. Just try to pick up whatever you can in class, okay? All right, so let's go. Let's try AM. What type of vector is AM? Excellent. So just to highlight these two things, how do I know that this is a position vector? What was the definition of a position vector? A position vector starts at the origin. So obviously, what letter is going to come in front all the time? Oh, so if I look at all of these examples, I have a few position vectors here. OA would be one. OB is another because it starts at the origin, O. OC is another position vector. And do I have another position vector? Yes. OP is another position vector. Then any vector that does not start at the origin is automatically a displacement vector. So let's look at all of the vectors that do not start with O. That would be DC, so that would be a displacement. BD, that would be a displacement. AM, that would be a displacement. All right? Everybody okay with that? And if you're not, I'm letting you know that this is something you must understand. So if you realize you don't understand it now, you write it down and you take some time to get into some notes or videos about it, okay? All right, so let's take a look at some examples. So I have these vectors. I should be able to make new vectors with these vectors. So the first one we're going to look at is AC. Now, AC means that I'm starting at what letter? A, and I want to end up at C. So something you need to take note of is that if I have OA, I also have AO, right or wrong? Because AO, so let's go back over here to the picture. If I have OA, OA is in one direction, AO is in the opposite direction. So if OA is positive. That means AO would be what? Negative. Everybody with me? So I could start off with AO. Why can I start off with AO? Because I want to get to AC. What up here also having a C and a O? These two. So I could use these two to create my new vector AC. So let's look at what we need to do. AO plus OC gives me what I need. We started off at A, we went to O, which is the common point. And since we're at O, we go to C. How do I know this is correct? The middle terms match. Everybody see that? And something you need to know. AO is just the reverse or inverse or the vector that goes in the opposite direction, OA. So all we have to do is switch it and make it negative, which is what we just spoke about, right? So let me just go on this side and make sure I kind of reiterate that. If I want AB, if I have AB, is it possible to get BA? Yes or no? Everybody, let's go. Is it possible to get BA? Yes. Because AB is positive because it's going in this direction. So that means that BA in the same exact thing as AB, except it's going to be what? Negative. Everybody with me? So if this was represented by P, if AB is P, that means BA would be what? Negative P. Hello? Are you with me? So if I have OB, OB is a position vector, but I don't want OB, I want BO. Can I get BO? Yes. It's in the opposite direction. So that means OB is the same thing as negative, sorry, BO is the same thing as negative OB. Okay? So I hope everybody with me with that. So here we have our actual formula that gives us AC. Now let's zoom out. Let's take a next look at the next one. I want to create AD. So I need to look for two vectors that have in A and D, and both of them share a common letter. So let's look. OA, OD. I don't have an OD, so I can't use AO and OD. But let's see if there's another vector that have in an A and a D that share a common letter. So let's look. A, what do I have? I have AC plus CD. Oh, I just make up these on the spot. AC was up here. Where did I get AC from? Was AC in the original list, everybody? No, but what did we just find before? We just found AC. So once you find it, this is also available to use. Everybody see what I mean? And the reason I did that is because CXC, that's how the questions just come. The first thing they're going to ask you, they're going to ask you to find something simple. Then the second question always tends to use what you found before to answer the question at the moment. So we have a AC, but do we have a CD? Let's look. We don't have a CD, but what do we actually have? We have a DC. Can't we use DC? But do what? Change it around. So we use AC plus CD because why? These two letters in the middle must match. Right? And then we know that CD is just the negative version of CD. All right? So I'm going to create a new one. So let me see if anybody could get this. I want to make OM. I want to make OM. So what two vectors I could use, everybody? And I'm going to start it for you. My vector must start with O. So which one of these here have an M in it? So I'm going to start with OA. Anybody could tell me what I need to match OA with to make OM? Excellent job. Everybody see that? It must start with an O. It must end with a what? M. A-M. Excellent job, everybody. Excellent job. Excellent job. Did I have to do any switching in this example? No, because everybody came the way I wanted it to, right? Excellent job, everybody. So let's try another one, a little harder. D-O. D-O. This one is a little harder. DO. You got several options with this one too. You could use a few options to get the same answer. So what can I use? So let's do some options. So let's see what is the first option. Which two vectors allows me to make DO? Somebody said DC and CO. Is that true? Excellent. That's true. Excellent. Everybody see it? And everybody realize why it turned into negative? So DC plus CO, but we have to remember, did I give you CO? I didn't give you CO. So it would have become DC minus OC. Somebody said DA and AO. Is that true? DA plus AO. Is that true? Does that work as well? But in this case, did we get a DA or we had to make a DA? We had to switch it in it. So what would I end up having to do? Make this negative. So this would be negative AD plus AO. If you got it, say got it. Talk to me, talk to me. Because if you can't do this, you can't answer questions, eh? I'm being honest with you. If you cannot create your own vector equations, you will not be able to answer the questions. So if there is any student that have not learned this yet and not 100% clear, that's fine. We got videos I could send you. There's notes I could send you. Okay, so just try to follow. All right, ladies and gentlemen, so that's what we need basically for vectors. Everything else I could teach along the way. So that's some of the things you need to know. You're going to need to know what it means for two vectors to be equal. You need to know what it means for two vectors to be parallel or two points to be collinear. And I think you also need to be able to write vector equations. Again, all of those I could teach using examples, so that's perfectly fine. Now, let's get into matrices. These are some things you must know about matrices. You must know how to add to matrices. You must be able to multiply a matrix by any constant, and you should know what a constant is, guys. A constant is a number, right? So you should know what it means to multiply. Let's take a look at something pretty simple. 4, 6, 3, 1. The first question I have is, what is the order of this matrix? Because that's something you got to know. What is the order of this matrix? That dot in the middle, what should it be? Remember when somebody asks you for order, it means how are the elements arranged? How much rows by how much columns, everybody? Yeah? So this would be a what? 2 by 2, because it has 2 rows and 2 columns. Everybody with me? So if I were to multiply this, all I know is I need to multiply each term by what? 2. So this would be 2 times 4, 2 times 6, 2 times 3, 2 times 1. Yeah, and you work out each answer. So that would be 8. Sorry, I don't know my pen sticking again. That would be 8, 12, 6, 2. Another thing you need to know is how to multiply by a fraction constant. So if I had a half, same numbers, 4, 6, 3, 1. What does this mean? When you multiply by a half, you should know it means the same thing as what? When you multiply by a half, it means what? The same thing as what? Dividing by 2. Right or wrong? So that means I have to divide every digit by 2. So there we go. So this is going to give me 4 over 2, 6 over 2, 3 over 2, and this one over 2. And as fraction rules go, you know that if you could break it down, you break it down. So we're going to end up with 2, 3, 3 over 2 can't break down any further, so you leave it just like that and a half. If you're sick, if you got it, say got it. All right, there's some rules that we need to know that I need to talk about. So the first one is you cannot add two matrices if they don't have the same order. So for example, if I have a matrix that look like this, 2, 1, 4, and then I have a matrix look like this, I can't add these two because they don't have the same configuration. They don't have the same arrangements. For me to add two matrices, they must have the same arrangement. So I could only add a 2 by 2 by a 2 by 2. Anybody could tell me what order this matrix have here? What order does this have? No, I see you, Naib. Excellent. Let's go talk to me. What order does this matrix have? I see 3 people, 4. Come on, talk to me. Because this is where you need to see if you know what you're thinking. All right, so I've seen people mixing up the two. Which number comes first always, guys? Rows by columns. How much rows you have? This is 3 rows. How much columns you have? 1. So this is a 3 by 1, okay? So for those who mix it up, I hope you see and understand. So you could try not to make that mistake again. And then this one is a 2 by 2. So what are the conditions for adding two matrices? They must have the same order. You realize why I keep repeating this? 2 years ago, the matrix question was just explain why. They're going to tell you something to do something and they're going to ask, these two matrices can't be added. Say why. That's a sentence. Imagine one of the answers to a whole question was sentences only, which means that you must remember the rules. Everybody with me? Hello? So do not just focus on being able to calculate. Make sure you understand why you're calculating, how you're calculating, when you should and when you shouldn't. All right, so that's addition. No. Multiplication is a whole different thing. How much people know how to multiply two matrices? I'm only going to do one example because today it is very important for us to do a lot of past paper questions. So watching the chat, talk to me. We got 38 people in here. We got 38 people in here. So the first thing I'm going to do, I'm going to do an example to kind of refresh your memory, and then you have to do one for me. How that sound? All right, let's go. So I'm going to start off with kind of odd looking matrices because everybody could do a 2 by 2. So I'm going to give you 3 matrices, A, and I'm going to use all positive numbers because I don't feel like being stressed out with you guys and integers right now, even though you guys should be able to manage matrix negative numbers. So it's just to kind of reduce the possibility of making mistakes, okay? All right, so my first question is, what is the order of A? Let's go, talk to me. Excellent. What is the order of B? Everybody should lock this one down by now. What is the order of B? Very good, a 2 by 1. What is the order of C? Excellent job, guys. That's what we're talking about. Excellent. You see how fast y'all talking to me like about this? That's exactly how it should happen. You know, that's the first thing you need to do. So now that we know each what do you call it? Each order, my first question is, can I multiply AB? Yes or no? And if you don't know, that's what we gotta fix. Is it possible to multiply A and B? I'm watching the chat. Talk to me. Talk to me. I see a lot of people say yes. Majority of people said yes. That is correct. How do I know that I can multiply A and B? What is the order of A? A is 2 by 2. times, what is B? A 2 by 2. How do we know we can multiply? The numbers in the middle match. Everybody see that? What are the numbers in the middle? 2 is what? The number of columns in the first matrix. Make sure you're clear, but this is a question that came up again. You have to be able to know the rule. The number of columns in the first matrix is equal to the number of rows in the second matrix. Everybody see that? Then this also gives us some information. It tells us that what type of matrix we will get as an answer. What kind of matrix are you going to end up with? I'm going to end up with a 2 by 1. Hello? So let's get this multiplication going. So I'm going to set up my question. So I have A, which is a 2, 1, 4, 3 by a 2 by 1, which is 2, 5. Now, I know I am going to end up with a 2 by 1, so I am going to set out my spaces. Now, everybody learned this differently. I teach it this way to eliminate mistakes because you know when you're stressed out, right? Everybody know when you're nervous, you would put 1 plus 1 is 5. Let's be real, okay? So anything that allows you to have safety and security is what we try to aim towards so that we could eliminate possible errors. So I know I need 2 rows and 1 column, so I'm going to draw 2 rows. That means you stack 2 and there's only 1 column, right? And then you draw your brackets. Now, another thing I'm going to do is I know I have to multiply. The rule for multiplying 2 matrices is that you have to multiply rows by columns. So I also circle my rows. So I know that this is how I should be grouping my numbers. And I circle my column. So I have a top and a bottom. And then I only got 1 column. Everybody see that? So let's multiply this. So you know you multiply, we're gonna get an answer for the top and we're gonna get an answer for the bottom. So you multiply the first 2. So the first thing in the row and the first thing in the column, which is what? 2 by 2. And then you add it to the product of the second 2, which would be 1 times 5. Let's do the bottom. What would be the combination for the bottom? Same thing. What's the first 2? 4 times 2 plus what's the second combination, the second set of numbers? 3 by 5. Now, for those people who know how to do this, anybody know how to back check to make sure your answers are correct? What must match? These two, the back numbers must match. Everybody see that? 2, 2, 5, 5. In addition to that, the front numbers represent your first matrix. Watch this. 2, 1, 4, 3. 2, 1, 4, 3. That's the back check to make sure your numbers are correctly arranged. So what is our final answer? 2 times 2 is 4, plus 1 times 5 is 5, 4 times 2 is 8, 8 plus 3. 3 times 5 is 15. So my final answer is 9 and what? 23? If you got it, say got it. So guess what you got to do for me now? My next question, we're moving along. All of this is revision. Again, if anybody is looking on and you have not learned this, or you learning and not feeling so confident, your job is to just try to pick up as much as you can like a sponge. Then you should be writing down, and this is for everybody, by the way. If we are doing something here online and you realize, but I may know this, I never learned this, don't sit down and abuse by your teacher. Your teacher ain't the one doing the exam. You have a responsibility to yourself. So you write down anything you realize you don't know or you don't remember, and after class, you do your research. Everybody understand what I'm saying? Hello? That's the difference between students who pass maths and students who fail. Is everybody fault why they fail, except theirs. All right, so there we go. Next question. Can I multiply AC? Yes or no? Can I multiply AC? The first skill in the exam is you must be able to know when you could do something and when you can't do something. Because guess what? If they ask you to find AC in the exam, you know an answer is there's no solution to this because you cannot. Why is it not possible to find this? Let's go. What's the order of A? The order of A is a 2 by 1 times what's the order of C? So hit me what 2 by 1. Sorry, that's a 2 by 2. I got a little excited there, guys. A is a 2 by 2. And what is C? A 1 by 3. What is the condition for me to multiply two matrices? The middle numbers must what? The middle numbers must match. Does this match? It does not match. So guess what your answer is? There is a solution to this question. You know what the solution is? There's no product AC. A and C cannot be multiplied. And if you're aiming for one, you say why it can't be multiplied. Because the number of columns in the first matrix, which is this number here, is not equal to the number of rows in the second matrix. If you got it, say got it. You have to understand. I was explaining to my class last week how the math profile is. And if you don't know what I'm talking about, when you get your results, whether you get 1 or 2, 3, 4, 6, there are 3 categories they're testing for: knowledge, comprehension, reading. Everybody understand? So everybody think, anybody care about the answer? Getting the answer would only give you marks on the knowledge. But if you are unable to communicate in this exam and explain that you know why you do certain things, that's where the comprehension part comes in. Okay, so always do as much as you can to get as much marks as possible. All right, so let's do the next one now. We can't find AC. How about BC? Is it possible to find BC? I feel like I am on fire, boy. I am on fire today. Is it because we're closer to the exam? I like it though. Very good. Excellent, guys. Yes, we can. Yes, we can. Because what is the order of B? B has an order of 2 by 1 times C has an order of 1 by 3. Does the middle numbers match here, people? No, this is actually a challenging question. Because what type of answer will I get here? When I done multiply this, well, it's not challenging. It's just a little confusing if you don't know what you're doing. So that's why I give this to you. What type of matrix answer will I end up with? Excellent. I'm going to end up with a 2 by 3. Everybody try this question for me now. So you got your B and your C. Multiply this and tell me where you get. So I'm going to write it here. B is 25 by a 3413. Everybody calculate that. If you get stuck, that's perfectly fine. The purpose for us today is to see where you're at, where you will get stuck so we could fix it. When you finish, you could either say done. If you're stuck, say stuck. And if you want to share your answer, share your answer. Okay, curve, you get 1640. Every single person should be trying this. Please remember, maths is a doing subject. You can't lay down in your bed and just watch this and expect these things to stick. For it to stick, everything we do, you have to be doing as well, okay? So even if you try it and you ain't share your answer, but you try it, that's all I ask him for, right? To be more, 1640. Guys, all right, how are you getting down? In a 2 by 3 we supposed to get. So So how I only gain 2 numbers? You see why I give I this specific question? It's just to test your ability to multiply. Because to be honest, you mostly get a lot of 2 by 2s, 2 by 3s, but I just wanted to make sure a question like this you could do. So let me try. So I know again a 2 by 3, right? What I mean, 2 rows, 3 columns. So I'm gonna draw that. 2 rows, 3 columns. So I draw out 2 rows, 3 columns. How much people stuck? Talk to me. Tell me the truth before I start. All I get set up. Okay. So we got somebody got some numbers here. So let me go. How much rows here? This is 2 rows. So we circling the rows, but this row only got one number. This row only got one number. So let's circle the columns. This column, this column, this column. So I'm gonna label these things. This is my top, this is my bottom. Everybody agree? This would be my left, this would be my middle, and this would be my right. So I would label all of these positions as well because they're going to tell me which numbers to use, right or wrong. So this would be my top left, bottom left, top middle, bottom middle, right, top right, bottom right. So there we go. This row only got one number, column only got one number. So that means all I should be multiplying here is the top and the left. So what is the top and the left? 2 and 4. So that's 2 times 4. Let me use red. 2 times 4. If this thing would allow me to write. So 2 times 4. What number should I use for the top middle? At least help me with that part there, please. Talk to me. What numbers I should use for the top and the middle? Especially if you know you ain't gonna answer. I see some answers from people. Excellent. Very good. It would be 2 and 1. Very good. Let's go. Top right. What's the combination for top right? Excellent. 2, 3. Bottom left. What's the combination for bottom left? 5, 4. Bottom middle. 5, 1. Excellent. Bottom right. 5, 3. So what should be your final answer then, ladies and gentlemen? Watch out, something so easy took y'all out, right? So 2 times 4, 8. 2 times 1, 2. 2 times 3, 6. 5 times 4, 20. 5 times 1, 5. 5 times 3, 15. I think Dante had this, or somebody else had this. Everybody see what's going on now? If you got it, you got it. All right, ladies and gentlemen, it's time for us to enter the dark side. Okay? Under the topic of matrices, these are the things you need to be able to do. You must know how to find the inverse of a matrix. You must be able to solve simultaneous equations using the matrix method. You must be able to add, subtract, multiply, divide matrices. And once you know that, in addition to the matrix transformation, that's basically it. So like I said, I'm going to use the exam questions to reteach or revise certain concepts, but once it comes down to the basic skills that you need to know, once you know to multiply matrices, that's your foundation. So let me make sure I make this clear. If you realize, just know you ain't as strong as you thought you were in matrix multiplication, take some time and practice a few. Okay? You do not, by any means, step into that exam without practicing and strengthening your weaknesses. All right? All right, so let me start off with, let me just make sure anything, I might come back to this after when we see a question on matrix transformation. But for now, let's just jump straight into the exam and see what we get. So we started with January 2025, which was the exam that just gone there recently. If you are ready, say ready. I'm watching the chat.
Done. This appetite, this plan to be more. Been here before. Life's better, time to break this better. Slowly.
All right. So, two things I want you to promise me that you do. If there's something that you realize you didn't know, you don't understand, you don't get frustrated. You stay open-minded, you stay focused, right? Two, I need everybody to be prepared to do the calculations for me. So everybody should have their calculators on standby. And even though I would be doing most of it, you still have to try to see if you would know what to do, right? Bet? Bet. Let me get started. Okay, first question. Now, once you see arrows, you know they start off with vectors, right? So you should start to get into the mental state of what vectors involve and how you should be looking at questions when it comes to vectors. So the first thing you always do, you see these statements, always read these statements and make sure that the information represented in the statement is shown in the diagram. If there's something that they say in the sentence and it's not in the diagram, what you think your job is to do? To use your pencil and draw it on. Because these are the things that allow you to kind of put the pieces together. Everybody with me? Everybody got it? If you got it, say got it. Students, I just see students doing an exam and they ain't write nothing on the paper. Like how you do the exam? That's why you're failing because you're not making connections. You're not representing the information. So this goes for every question. You read the caption, you read the title, you read the instructions, you make sure you're drawing match. So let me go. The diagram below shows a quadrilateral OLMN. So the first thing I'm going to do is make sure you know where all these letters be. OLMN, that's the overall shape. All right. Even from first glimpse, I noticed that this shape is broken up into two triangles. So I don't pre that scene. Okay. And I'm going to see if they mention that in the caption as well. So I understand the first part in which O is the origin. No, because O is the origin, what does that mean? What type of vectors we have here then? Anything starting at O is what type of vector? A position vector. Everybody with me? You see how they're telling us things without telling us things? So another thing we need to know is even though there's no graph lines, this is the origin. That means 0, 0. All right. So then it says now in which the origin OL is 4y. So let's make sure we see that OL is 4y. So it's in the picture. So I understand. Boom. OM is 6z. I look in OM. Where is that? 6z. While I am doing this, you know what I also telling myself in the back of my head? If OL is 4y, what is LO? Anybody? If OL is 4y, LO is what? Negative 4y. Hello? Nobody's supposed to even tell you this, eh? In the opposite direction, remember, you're going in the opposite direction, is in the opposite, is going to be negative 4y. Yeah? That's something you have to keep in the back of your head. Excellent. Let me move. So same thing with MO. So I have a OL, I have a LO. All of these vectors are available to me to use, right? And sometimes the best thing to do is even write it on the side so you know when it comes down, you know what options you have. So we have OL and we got LO. We got OM and we have MO. Let's go. Then we got ON, which is what? 2x. So if I have ON, that means I also have what? NO. Now, let's continue here. The point A lies on LM. But let me ask you a question. What does LM represents? LM, what type of, is LM a vector? That's a serious question, by the way, yeah? This is for everybody. Is either yes or no. Talk to me. All right. Okay, so this is a little tricky, so I want you to pay attention. Based on the diagram, it is not. Everybody realize that? Because it has no arrows. And even if you look at it here, you realize all the displaced, the position vectors have the line above. So directly based on imagery, it doesn't represent a vector. But we know that the movement, once you dictate there's a movement from one point to the other, it is a vector. Everybody with me? So I want you to be clear because students get confused with that. But what type of vector is it? Is it a position or is it a displacement? Excellent. And once you know it's a displacement, what should be coming to your mind? In the triangular law, where we make up our own formula to find it. Everybody remember when we was practicing before? So that is where that comes in. If you understand what I'm saying, say got it. So you understand the difference between your position vectors and your displacement vectors. Your position vectors are direct. It's given to you. You realize it has a quantity next to it, your 4y, your 2x, your whatever. But then your displacement vectors do not. You have to generate how to get these vectors by using the triangular law. All right, so let's read some important information. So it says here, right, that the point A lies on LM, so we're watching LM, such that LA, so we're going LA is one part and AM is two parts. Anybody realize this is ratios? No, I have a question for you. How would I represent LA as a fraction? Let me see who's thinking. I want to represent LA as a fraction and I want to represent AM as a fraction. How do I do that? How much parts we have in R? So what is the denominator for every? Okay, boy, Gab, you're on a roll. Excellent. Is a third. Why is it a third? Because if this is one part and this is two parts, how much parts is it in all? And then how do you know it can be a half? Look at where this drop. Is this halfway? No. This is a third way. Everybody see that? Everybody see the connection? Where you look at it and then you make some conclusions based off of what you see also, even though you can't really rely on that, eh? But it's just about making visual connections in this case. So if you got that part, you got it. So that means LA is a third of the whole line. And what's the whole line? LM. Similarly, AM would be what fraction, guys? AM would be what fraction? 2/3 of LM. Because if you remember, a third plus 2/3 give you 3/3, and 3/3 is a whole. You realize, man, even check anything. I don't write down the information here because that's what proactive math students do. Because then when you read the question, you have a lot of the information that you need to use already on standby. Everybody understand what I'm trying to teach you? May really care about the numbers and the question itself. And I'm trying to teach you how to read the question, how to set up the information so you know what to do when they ask you questions. Hello? Are you with me? Let me know, please. All right, so let me run it. So that's the first line. We don't separate this. So we don't know what we got to do if we ever had to find LA. We know what we got to do if we ever had to find AM. So I can't find LA without one line. I must have the whole line, yeah? Okay, so let's do the next thing now. And point B, find it, is on MN. And you realize they give you the direction. LM is the direction. MN is the direction. Such that MB is 2 is the other way around. So this would represent 2/3, and here would represent a third. Pretty straightforward now, right? All right, ladies and gentlemen, are we ready to answer the questions? No, you're not. We're not answering these questions and you're waiting for me to tell you what to do, eh? Everybody should be in the mindset to see if they could figure it out before I even say it. So let's go. Let's zoom out. We have everything that we need. Express in the simplest form MN in terms of XZ. Stop. What do you mean by this? This is what we call vector equations. So I'm just going to pause and come to the side and explain this quickly. Everybody know what vector equations are? Yes or no quickly? Talk to me, talk to me, talk to me. Vector equations, vector equations. So let's take an example here. If I ask you to find AB, what's the first thing you need to write here for AB? AB would be my what? My displacement vector. So we got to write with formula. So somebody tell me the formula to find AB using our vectors here. What do I start off with? I start off with what? No, no, no. Remember you're using your capital letters. So you're going to be AO, very good. Plus what? Somebody finish, assist, assist. AO plus what? Anybody? Cat, OB. Everybody see where it's OB? One must be in the middle. One must be in the center. OB. It must match. Right or wrong? So the ending, the start is the A, B. But what do we notice here? Do I have a AO? No, I need to go what? I need to do a negative OA. So there's going to be negative OA plus OB. Yeah, everybody see that? Because we're going in the opposite direction. No, let's write the equation for that. If I want to go from A to O, what type of M is that? Your vector equation uses the small letters to give you the answer. So I don't even need this part here. You could actually follow it using your official formula here. I want to go from A to O. What is the small letter for A to O? If OA is positive, that means AO is what? So you're going to be negative M. Everybody see that? Plus what? Plus P. Because we're going this way and then this way. So you see why the negative OA comes in? Everybody see that? Plus OB. If you got it, say got it. So let me explain how to make sure you understand. Your vector equations uses your small letters, the pathways of the small letters. So after you get your formula using your big letters, your capital letters, it shows you the pathway, then it tells you how to use your small letters to get from one place to the next. So using a simple example, let's get this done. So it says here, express in the simplest form, MN. So MN. The first thing I need to do is figure out how to get from M to N. Anybody could tell me how we're going to get from M to M, big letters? You could even use the picture and follow the pathway. It's easy if you follow the pathway. You're starting at M and you want to reach M. What do? I'm going to go M to O. Tell me if I seen it there, right in the picture. M to O plus what? In O to N. O to N. Everybody good? No. What do we know? That we need to use the small letters, right? Because we don't care about the big letters because they ask for what? In terms of X and Z. And you see why they say X and Z? Because your small letters are X and Z. So somebody tell me, what is MO? MO would be what? Excellent. Negative 6Z, right? Plus what? Excellent. No, let me teach you something right now. What CX expecting from you to do here is to factorize as well, eh? No, this is the same thing as this. Let me see if you all know that. 2x minus 6z. Everybody know that's the same thing? That's important, yeah? All right, so everybody with me? No, I don't know why CX you ain't gonna do all of this here, Fab, because look how we get the same answer. Everybody see that? Exactly like that? So the point I was saying now is the factorization part. Anytime you could factorize, you could factorize. So we reach here. So sometimes it's important to pull up what's common. What 2x and 6z have in common? They got 2 in common. So if I pull out 2, we're going left back. And, you know, pull out means divide by 2. This is going to give me what? X minus 3. Z. Sorry, I forgot the Z. So everybody see that? Always write also the factorization version because it's going to come in handy at some point. All right? So everybody okay with the first question? Talk to me. That was the first question. Pretty simple, right? Once you understand what to do, once you understand where your mind's supposed to be going, what you're looking for, how you should be thinking. All right, so let's move on. The next question says, find in terms of X and Y the simplest form for Ln. So now we're going to find Ln. Ln. Talk to me. What's the formula for Ln? Excellent. I love what I'm seeing here. Everybody agree? Ln. So if I follow in the vectors, it would be LO plus ON. LO plus ON. So what would I have for LO? Let me see who's thinking. What will be the vector equations for this now? Excellent. Negative 4y. And why is it negative 4y? Because we're going in the opposite direction. And I'm looking at my chart and I'm not feeling I'm not satisfied with the amount of people participating, so I just keep saying that this is my first warning. You ain't got to answer every single question, but you should be trying to answer as much questions as possible, yeah? And they got some people that seen over and over and over, and then they got some people may seen nothing from. Please. Thank you. So we got negative 4y plus 2x. Should I leave it like this or we factorizing? So I could rewrite this in the other way as well. 2x minus 4y. So you could change it around to make it easier visually. And then you take out the 2. So you're going to be 2x minus 2y. Do you agree? Because we divided by 2. If you got it, say got it. Watch how easy this is. All right, let's move on. B, check this out now. Show that A, and let me tell you something. When they say show that means that this is the answer. So that means they expect you to find this, and when you find this, it must look like this. Even if you do it and it don't look like that, you have to find a way to make it look like this, right? That's the trick part about it. So show that, prove that. That's what I mean. So let's go back to the picture. What they want us to find again, AB. So look at this drama now. Watch where A is. Watch where B is. But we know some information, right? We know some information. So my question to you is, do you know what to do? Would you know what to do? Tell me the truth. What should be your first step in everything you do for maths? Is the 4 steps. Step 1 is what? In formula. Step 2 in substitution. Step 3 in working, then answer down what we've been doing all along. Let's go this in formula here. When we find the formula of how to get from one place to the next. And then substitution is where we look at which part we're talking about, and then we work it out. That's the key. If ever you don't ever know what to do in something, that's where you should be thinking, okay, does this have a formula? Is this something I need to follow? So let's go. We want to go, what they ask for, AB. So we need to create a formula for AB. So based on the pathway, what lines should we go? If I want to go from A to B, what should I be following? What's the formula for AB? Based on the picture, what pathway you would use? Look at the letters. AM, excellent, because I will go from A to M and then what? M to B. Right or wrong, guys? A to M plus M to B. Everybody see that? That's your first step, right? The next thing is now is how do I get AM? What information tells me about AM? That's where you go from there, because based on what you look for before, you have to look at what information you look for before. Before we found MN, and then we also found what in LN. So we know the equation for this full line. Everybody dying what we found before. We ain't found the equation for LN. Where it gone? We ain't found this already. So AM in 2/3 of that line. Excellent, Vanny. Everybody remember that? Hello? Remember when we talk about the 2/3? I know it's kind of confusing here, but tell me if you understand what I'm saying. In the previous question, we found LM. Is that not true, guys? So let's take a look at the working just for us to save sites. All right. So, oh no, we didn't find LN. LM, they found LN. So for us to find AM, we got to find LM first. I thought it was LN we found, but it was LN and not LM. But LM is easy to find, isn't it? How you find LM? LM in just LO plus ON. That's an easy thing. That would just be 4 negative 4y, right? Plus 6z. Talk to me if that ain't true. So let's look at the work in here. Yeah? Look at there. I want to make sure everybody with me. If you got it, say got it. Because for us to find a section of the line, we must have the whole line. So now that we know what the whole line is what? Negative 4y, 6z, right? So let's go. AB, we also know the formula for AB already. AB is AM plus, let's look here, AM plus the MB. So we know what AM is. AM in the 2/3 part, the 2/3 of the whole line. So let's come down here. What did they find? 2/3 of LM plus, look at MB as well. MB was in the 2/3 section as well. Look at here. So everybody see why I told you to label these things in the beginning? Everybody see how easy it is for us to know, work it out, because we already put that information there. If you had just gone and started working it out, you would have never realized, oh, I done got the fractions. I just need the whole line. So everybody, if you understand that concept, say good to go. And when I say understand the concept, you understand how to use the fractions, how do you find each small line, and how to put all of it together. So we're gonna go through it with the working so you can see how to answer everything, and then we're moving on. So we're paying attention here now to the working aspect, yeah? So we found out LM because we worked it out before, which looks similar to another equation, by the way. I hope I realize that. Plus 2/3 of MN. So guess what I did? Because these two have the same fraction, anybody realize they pull out 2/3 and they put everybody else together? This is algebra now. Tell me if you understand the algebra from here to here. Yes or no? It's just like factorization. You pull out what they got in common, you put it on the outside, and you put everybody else in the bracket. So factorization, algebra is a major part of matrices and vectors, if you didn't realize that. Yeah? So then from here, what do we know? We know how algebra rules go. We add and subtract like terms. Do we have any like terms in here? Yes, we do. We got as plus 6z minus 6z. And we know that these are the opposites of each other. So what are they going to do to each other? They're going to cancel each other how? Out. Everybody see what's going on? So that's how we end up with this. So this is our final answer. If you got it, say got it. Just like that, we answered the first part of vectors. And I'm telling y'all now, this is in January of this year. So it could mean that something similar on a higher difficulty level can come. Yeah? All right, so let's move on. Based on your results, state 2 geometric properties related to LN and AB. First thing first, you need to know what they mean by geometric properties. Remember earlier I said that you're going to hear things like if two lines are either equal, two lines are either parallel, and everybody know what parallel means, right? They're going in the same direction, right? And then if two lines or points are collinear, that means if this all the points them on the same line. That's what that means. Okay? So it says two geometrical properties. No. If two lines are parallel, one is a multiple of the next. So let's test if you understand what I mean. Suppose I had a line AB, and AB is A plus P plus Q. Let's use P plus Q just so we don't get confused. P plus Q. And then I had another line LM, and LM was 2P plus 2Q. Are these two lines parallel based on what I just said? Is one line a multiple of the other? This is a serious question and I need everybody to answer me. Are these two lines multiples of each other? Is there a number I could multiply to one to make the next one? Ladies and gentlemen, I can't believe this. You all are so right. Very good. Because what would be K? K is the constant that we're multiplying by. What would be K in this example? Who could tell me? Excellent. Excellent. Because if I take PQ and I multiply P plus Q by 2, I would end up with 2P plus 2Q. So that means one is the multiple of the next. So that means they are parallel. So I just use an easy example to make it clear. Obviously, CXC would never give you this, because they're very evil. So once you understand what to look for, though, that's fine. Here's a trick to determine that, though. You divide this by this. So you divide 2P by P, and then you divide 2Q by Q. And if the answer for this is the same as the answer for this, that number is your K. So if I cancel this, what am I going to get? 2. If I cancel this, what am I going to get? 2. So that means K is equal to 2. Everybody see that? Hello? Because sometimes it's a fraction, sometimes it's a decimal. So you can assume that it's all going to be whole numbers, right? All right, so let's take a look at this example and how do we look for it. So one was 2/3, because we found AB. So AB was the answer we had before. So you write it out first to see if it's obvious. So, we found that earlier. Well, wherever it is, it's somewhere. Look at there. That was the answer for AB. Lord, guys, I lost it, Okay, look at there. So that was the answer for AB. And then this one was the answer for LN. Isn't this one obvious? Everybody realize it's obvious here? And in this case, what is our K? Our K is a fraction, just like I mentioned before. Our K is what? 2/3. So therefore, they are parallel. If you got it, say got it. So let's give me some feedback now. How was your first vectors question? Was it that hard? Do you realize that, it's pretty straightforward if you know what to do, if you know how you should be thinking, how you should evaluate the picture? Wow. Wasn't bad, right? But remember, January exams are always easier than June. So please write down, everybody should be writing down things that they realize they're weak in so that you know how to study, how to practice, right? Okay. All right, let's go. Now it's time for the matrices questions. So let's start with this one. Determine the values of the matrix in the equation below. So the first thing first, this is an easy question. Why is this easy? Because this is addition. Now there are letters in this. What are the rules for adding matrices? And I'm going to try to use different colors. If I add 4, the only thing I could add 4 to is x, and that's going to give me -3. So I'm going to go to the side and I'm going to write the equation. 4 plus x is equal to -3. We can't find out what x is. You realize algebra here again? Everybody realize algebra is here again, which is why I was always saying that algebra is your most important topic because everybody expect you to know that's what you're supposed to be doing now. So we transpose by moving 4 over because we just want x. When we move positive 4 over, it's going to become 1 negative. So x is equal to negative 3 minus 4. So x is equal to what? No calculators. Negative 7. Excellent. When the signs are alike, you add the numbers, you put back the sign. Everybody with me? There we go. Now, this one is obviously straightforward because look at this. 0 plus 2 is 2. Let's do one that have matching as well. Let's do green here. 5 plus negative 1 is 4. So only these in the same color could interact with each other because based on the rule, you could only add terms in the same position, right? So what is our next one? How do we find y? We do the same thing. We say what? Negative 2 plus 8 is equal to y. So negative 2 plus 8 is equal to y. So what is y? How I get 5? When the signs are different, you subtract, your answer takes the sign of the bigger number. Y ain't 6. If you got it, you got it. Now, listen to me, guys. If this was multiplication, what would you have done? A, multiply like normal with the letters and then do the same thing like what I just did just now. So if this was multiplication instead, you do the same thing where you draw out your lines, you get your answers, and then you match it. So the answer for here would be the first number, the answer for here would be that, and then you use algebra to solve. Everybody with me? So even though this is addition, it's the same concept with multiplication. All right, moving on. Pretty straightforward. Don't forget, after every question, you always make a statement with your answer. So therefore, x is equal to negative 7 and y is equal to 6. Always make sure you give your statement at the end. Okay, let's move on to the next question. Oh, they say the same exact thing I just said. That could come. But me ain't seeing the question. Is me? Okay, I guess the question is here. Okay, so there we go. This is the exact same concept. So everybody paying attention? Instead of addition, what do we have to do here? Multiplication, right? So we multiply like normal, but what do you realize? We got A and we got C. So we got to find the answers for A and C. Over here is the answer. So we ain't really focus on this yet. We just focusing on doing what first? Multiplying these two to get a common answer. Can I multiply these two? Yes, because the middle two numbers match. What type of answer am I going to get? I'm going to get 2 by 2. So I'm going to do this my way because I don't like how they did this here, right? So first thing I'm going to do is what? Circle my rows. This is my row. This is my row. What am I going to call this? Top. And I'm going to call this what? Bottom. Over here, I'm going to circle my columns. What am I going to label this? I'm going to label this left and I'm going to label this right. So I know I'm going to get a 2 by 2. So I'm going to do my 2 by 2 space, 2 rows, 2 columns space. Everybody ready? If you're ready, say ready, please. Excellent. So there we go. So as you know, how are you multiplying two matrices? Rows by columns. So it's always the first one in the row and the first one in the column. You multiply that together and then you add it to the second one and the second one. So there we go. What's the first combination? This is the part I got to tell me because this is practice for you. What's the first combination? So we got top, left, bottom, left, top, right, bottom, right. So these tell you which combinations to use for each line. So we're doing top left first. So what's the first two in the top left? Excellent. 5 times A. Everybody agree? So the first two is 5 and A. Plus, what's the second two? Remember, you're going down because it's in left. So you use the 5, you use the A. So what left? What's the next combination? Negative 3C. Excellent. Everybody agree? That's why I'm asking y'all to do this, huh? As easy as it looks, just watching, you have to know how to get the combinations. Let's do the bottom left now. Everybody, what's the combination for the bottom left? Bottom, we're using these two numbers now, and left. So what's the first two? Excellent. 2 times A plus, very good, guys. 3 times C. Excellent. How we looking so far? Our back numbers matching, so we looking good. A, C. Okay. Now let's do top right. So top right. Top right. Let's go. 2A plus 2 times A. That's not correct. You see why I asked I to do the combinations? Top right. Excellent. 5 times 2. Remember, it's the first two. The first one in the top and the first one in the right. Hello? So let's go. Plus what? What's the next combination? So we got 5 times 2 plus what? Negative 3 times negative 1. Excellent. Bottom right. Bottom right. 2 times 2. Excellent. 3 times negative 1 plus 3 times negative 1. So let's see if that's correct. A, C, 2, 2, negative 1, negative 1. Let's check to see if the front numbers are right. So the front numbers should match the first matrix. 5, negative 3, 2, 3, correct? 5, negative 3, 2, 3. So now it's just for us to do our calculations, but we need to also put it is equal to the answer. So we got to put this part, negative 10, 13, 17, 1. Yeah? So let's go, guys. Talk to me. What's the answer for the top left? Five A. Anybody? Minus 3C. Remember, when these two come together, it turns to a minus, yeah? Bottom. 2A plus 3C. Excellent. Over here. 10 plus 3. Everybody see why it's 10 plus 3? A negative times a negative is a positive. And the bottom, 4. This is supposed to be a plus, sorry. Was it? Hold on there. Yeah, 4. What this was supposed to be? 3 times 1, negative 1. Yeah, sorry, that was correct. 3 times negative 1. I don't know where that extra thing came from. It was 3 times negative 1. So that would be what? Plus minus 3. Equal negative 10, 17, 13, 1. So let's see if we're going good. So I can't do nothing with this because it's two different terms. So you put back 5A minus 3C. 2A plus 3C. 13 and 1. Everybody see what's going on now? What do I do next? Everybody realize now, watch this. 13 and 13 match. 1 and 1 match. So what do I do next? Don't I put these two numbers equal to each other? 5A minus 3C is equal to negative 10. 2A plus 3C is equal to 17. This ain't look familiar. What topic is that? What topic is this? This is simultaneous equations. This is what? This is algebra. Hello? Everybody see the point I've been making all along? you're not good in algebra, you're gonna fail. Let me just be 100% honest with you. If you couldn't look at that and realize immediately that that's simultaneous equations and what you need to do next, you fail. Why they make it easy for you though? So I'm gonna bust through this quickly because we went through this on Sunday already as well. What would you do in this case? Add or subtract? I would add. Why would I add? Because these two ain't matching already. So if I add these two, they would eliminate each other. So I would end up with 7, sorry. I would end up with 7a plus 2a plus 5a is 7a. This gonna give me 0 is equal to, and this gonna give me 7. Hello, Wayne, looking like we're cooking on gas, things ain't lining up for us. So 7a is equal to 7. So we divide by 7 on both sides. So obviously, what is a? This is gonna cancel, so a is equal to 1. Once we know 1, what is this next step for simultaneous equation? In substitute. So we take a is equal to 1 and substitute it into any one of these. So I could even use the second one. So let's say 2 times 1, I'm using the second equation, plus 3c is equal to 17, right? So 2 plus 3c is equal to 17. I transpose, carry this over. 3c is equal to 17 minus 2. 3c is equal to 15, divided by 3, divided by 3. C is equal to 5. So what's my final answer? Therefore, A is equal to 1 and C is equal to 15. If you got it, say got it. Look at us doing simultaneous equations in matrices. You see why it is important to be strong in the things you need to be strong in? Hello there. And honestly, they were very kind for it to work out like this because look how easy it was for us to find A. And to be honest, finding C was just as easy as well if you know what to do. All right, so let's keep it moving. So far, so good. So you see, we got the answers here. Guess what? That's the first exam. That's it. That was January 2025. Rank it based on your understanding in terms of how you feel after we gone through the whole question. Do you feel like you understand what we did? Even if you didn't know it before, we're talking about how you feel about it now. Like if something like this was to come again, how you feel like you would be able to perform out of 10. I watch in the chat. Keeping in mind, you also should be paying attention to the things that you are not strong in, the things that you don't know, the things that you need to practice. AKA algebra. Okay. All right. Are you ready for June? Which is going to be on a higher difficulty level? Talk to me. Y'all ready? If you're ready. Hey, I guess something weak, not me want to hear, I guess I want to hear yes, period, poo. Come on, let's go put your backs into it. Let me see you do it. Let's go. Are you guys ready for another exam paper? And this is June. This is the year that had the highest failure rate in 7 to 10 years. So another thing you should do when you're going to past papers is seeing where you're stacking. Like if you know everybody in the Caribbean failed this exam paper, would you have failed? Like that's what you're supposed to be checking and seeing where you stand. Would you have been able to answer this question, especially after classes? All right, so let's get straight into it. June 2024. Read the first question. It says here, you realize here they switch it around. They start with matrices instead. So we got to be able to go in. I love this question here. The determinant of the matrix. If you know the formula for the determinant of the matrix, say yes. If you don't know it, say no. Because I just need to know who know it and who don't know it. The formula for the determinant of any matrix. Do you know it? That's very good. So it seems like nobody said no. So that's a good sign, right? Excellent. So everybody should know the determinant of any matrix is AD minus BC, right? And you should know which elements is A, B, and C. So this would be your A, your B, your C, and your D. All right. While we're here, everybody know what it means for a matrix to be singular? I just want to talk about it quickly. If they say a matrix is singular, do you know what that means? Do you remember? I should ask. Do you remember what it means? Be honest, quick, 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 quick. So I could do it now or I could move on. It means that it is the determinant. If a matrix is singular, that means that the determinant of that matrix equals zero. That means when you work out the answer is equal to zero. This is very important. This word is very important. All right. If you didn't remember it now, lucky to you know. Singular, if a matrix is singular, the determinant is equal to zero. All right, so let's get back here. So they give us some variables. So, you know, we got to do some algebra and they give us the answer. So what do I substitute? You know, formula, step one, substitution, step two. So somebody tell me what numbers I should put here. What is A times D? What is A in this example? Anybody? Excellent. 6 times what? Negative V. Very good. Very good. Minus, what is B? What is B? B is 2V times negative 5. And all of this is equal to what? All of this is equal to 24. It didn't say singular. I was just teaching you what singular mean. If they had said singular, then it would have equal to 0. So apologies. This example gave us an answer. It says is 24. Okay? If they had said singular, then you'd have put it to 0. Clear, right? All right, so let's go from here. Algebra again. So what would this become? Negative 6V. Do we agree? For 6 times negative V minus, what we gonna end up here with? A negative 10V equal 24. Everybody agree with this? And then next, what's gonna happen? What's the next move? What's the phenomenon happening here? What is the situation we're faced with at this moment? What is the next thing we have to address? The clashing signs. Yup. So this negative and negative gonna turn positive. So this gonna become negative 6V plus 10V equal 24. So we should know the rules. What's the answer? Negative V, 6V minus 6 plus 10. And we're supposed to be able to do this out of the head without calculators, by the way. So what is this? Negative 6 plus 10. The signs are different. The signs are different. So we subtract and our answer takes the sign of the bigger number. So your answer is 4V, no square because we adding and subtracting CAD, right? Is equal to 24. And then what do we do next? Just transpose. We divide by 4. Whatever you do on one side, you do on the other side. So V is equal to 6. If you got it, say got it. Everybody realize why I keep saying question 10 is an easy question to mash up. No crumbs. Once you know your rules and you practice, you good to go here. All right. Excellent. V is equal to 6. Now, next question. Matrices L and M are defined below. Evaluate each of the following. Find LM. Everybody do this for me now and tell me the answer. I'm not doing this. We did this before. So your job is to give me the answer and let me know if you're either on track or not. And you don't have 24 years. You literally got 2 minutes. Because we also need to start training ourselves to do things quickly on the exam pressure, on the exam time. So let's see who could make this challenge. 2 minutes, that's no. And I'm watching to see who share the answer. Good. Your answer will be a 2 by 2 matrix, but you have to actually work it out for me. No, it's gonna be our. Let me see. Me ain't saying nothing. Me ain't want to say nothing. Just post your answer. I want to see something. Let's go, guys, because this is what gonna tell us what we're working with. This is gonna tell me how ready you are. Send me a final answer. So, all right, sending me the working, thank you. But what is your final answer? So send me if there's a number in the top and a number at the bottom. What are your answers? What is your final answer? You still have about 5 seconds left. Time out. So some people saying -2 for the top and the bottom. Some people saying -1, -2. Everybody, let's go. Let's go. Come on. If you can't get an answer for you, that's a problem, yeah? That's a problem. You must be able to get something. So I'm gonna start working it out. Let's see how far you got. Let's see who's on the right track. So first thing first, I am going to say the order. This is a 2 by 2. This is a 2 by 1. That means I can multiply because the middle match, and that means I'm gonna get a 2 by 1. So I'm gonna get 2 by 1 means I'm gonna get 2 rows and 2 columns. That's a top and a bottom. Yeah. So that's how I know everybody's cooking on gas. So I'm gonna circle my 2 rows and my 1 column. This is my top and this is my bottom. So this is my combinations. The first two is 9 times 2 plus 5 times -4. Then the bottom combinations would be the first two, which is 3 times 2 plus 2 times -4. Before I continue, I back check to make sure I'm right. Times 2 times 2 times -4 times -4. Front numbers 9, 5, 3, 2, correct? So that means this combination is correct. So next step is to work it out. So that's 18 minus 20, and everybody should know why, because this is going to give me -20, and positive and a negative going to give me minus. And this is going to give me 6 minus 8. Same thing. So my final answer is, drum roll, -2, -2. If you got that, excellent job, guys. If you didn't get it, I hope you see where you're making mistakes and you work on it. All right. Are we good to go? If we're good to go, it's good to go. Because we're not here to do a lot of talking. We're here to get this thing done. We're here to pass. All right. I'm glad the next question is L inverse. So my next question is, how much people remember the formula to find the inverse of a matrix? Yes or no? Be honest. If you was to do this straight from scratch, do you remember? Because I know you learn it, but is if you remember. Thank you for your honesty, ladies and gentlemen. So let's get it. No, this formula is a formula that you have to memorize. It's not going to come in the exam. It's not on the formula sheet because we did that. So we know what come on the formula sheet already. And everything on the formula sheet more so caters to measurement, right? Question 6. So you have to memorize this and try to do so as of today. So for those who don't remember, let's go. Vanny, thank you for your thing, your assistance. So L inverse or any inverse is equal to 1 over the determinant of L times the adjoint of L. Hold on. My thing stick. Does that sound familiar, peoples? Am I drawing your memory? Do you remember now the adjoint of A? So we already know how to find the determinant. So we're going to find the determinant first. And you know, the formula is AD minus BC. So tell me the numbers for this, please. Look at here. So you know it is 9 times 2, 18. And BC is 5 times 3. So our answer is 3. If you got it, say got it. So I just kind of make sure we move along quickly so we don't spend too much time. So talk to me if everybody okay with finding the determinant, say got it. And now, how do we find the adjoint? The adjoint is 2 steps, right? What's the 2 steps? You switch A and D, and you multiply B and C by -1. So this time -1 and this time -1. So what is our adjoint? Our adjoint 2 gonna be up here, 9 gonna be down here. This was positive, so it's gonna be -5. This was also positive, so it's gonna be -3. Everybody remember this now? If you didn't remember it, lock it in. Switch the A and D, multiply B and C by -1. So let's substitute into the formula. So there we go. We're substituting. So that means that's 1/3 times the adjoint, which is 2, -5, -3, 9. Now, based on what I need you to do, would let you know, should I leave it like this? Because to be honest, you could work this out further. How do we work this out further? This will become 2/3, -5/3, -3/3, and 9/3. Yeah? And this could be broken down more. So this would be 2/3, -5/3. This would be -1, and this would be 3. If you got it, say got it. Can we talk for a minute? All right, so that's our answer there. As we see here, that's the answer. Good. Now, fine. Oh, I want to know what's going on. It's so confused. I was like, what is? All right, so let's move on, guys. PQ is equal to 5, -4. If P is the point, if P is point, -2, 3, determine the coordinates of Q. Oh, I like this question. I love this question. So let's read this again. PQ is 5, -4. If P is the point, -2, 3, determine the coordinates of Q. Does everyone know what to do here? Do you know what to do here? Somebody give me some suggestions. What do you think you need to do? What operation you think you need to do here? Think about this first of all. Look at the information. What topic we into now? Are we still in matrices? Or we move on to vectors? Everybody realize we're on vectors now? Also, keep in mind, what does vectors represent? This is what type of vector? This is a displacement vector, right or wrong? So that means that to go from P to Q, what type of movement does that require? What does 5 represent? Then a positive movement. So that means to go from P to Q, I had to move 5 times to the right. Right or wrong? And that means in addition to that, where else did I have to go? I had to go where? Where else I had to move to? So is either right or left or up or down? So which one I had to move to? 4 down. Everybody see what's going on now? Hello, talk to me. What they're also telling you now is your original position. What was your original position? Your original position in -2, 3. So who could tell me what you think we should do? What should we do to find where Q is? What do we do with these two numbers? What should we do? Because remember, if you're going from P to Q, that ain't a movement from one point to the next. And we know the movement. Somebody say add. Anybody else? Because, yeah, these are the things you got to figure out. Somebody says subtract. Come on, everybody, let's go. Share what you think you need to do. Would you add? Would you subtract? What do you think you got to do? I need some more people to talk. So let's go before we find out the actual answer. Ladies and gentlemen, is an add. Because think about it. PQ in equal to PO plus OQ. Hello? Hello? But even think about it. Just think about it. You want to go from one place to the next, and they give you the movement. It's an addition movement, right? And think about it as well. If they give you the points, let's go back here. The point A mean that that's displacement vector, because once they give you the point, do you know that point P is the same thing as OP, the position vector? So that means OP is negative 2, 3. Talk to me if you're with me. You got to make these connections, lovies. If you got it, say got it. You know, the content is just about how to think. Is it line of thinking? So that's an easy fix. We add, we get we answer. So that's how we know where Q is. And please note, everybody see why it is possible. All Q is a position vector. That means it's a point in relation to the origin. So I could take OQ and turn it into a point. I could take a point and turn it into OQ. You cannot do that with a displacement. Displacement is a movement. 1, 5 to the right, 4 down. See the difference? All right, let's keep it moving. So just say that we finish that. I love these things. I may know why, but I feel like these vector equations is like a puzzle. I didn't realize it's like a puzzle. Like a little map, and you gotta figure out where to go and what to do. All right, so are we ready for our vector equation question? So let's go. In the pentagon OABCD, OABCD, so all my points are here, it's a parallelogram. So I don't know where I saw that. That's my dyslexia. Just letting y'all know that sometimes I would see a word but still call another word. So forgive me. So it's parallel to DC. So let me see if I understand what's going on here. Thank God for the arrows. Right? So we know this line is parallel to this line. What does that mean, guys? If they're parallel, that means that this is a multiple of this. So that means OD, and this is something you should know, right or wrong, that if AB is B, that means OD is a multiple of B. Hello, are you with me? It's either 2B, 5B, 6B, we don't know how much B is, but it's a multiple of B because they're parallel, right? And the same thing, OA. So let's see if we can understand, make sure DC, let's go, DC is parallel to AB. Hold on, everyone. OBC is parallel to DC. And AB is parallel. I think they make a mistake. I think they were supposed to say CD would based on the picture, right? You know, it makes sense. Because it's just a little confusing. So these two parallel and these two parallel. Okay. OD is 2AB. So that means that if OD is 2AB, what should I label here, everybody? Let me see what thinking. They tell us no, the multiple. So what should I write here? If up here is B and down here is 2 of AB, what should I write here? Closed mouths don't get fed, eh? So let's go. Mary said 2b. Is that true? B square. Where you get a square from? 2ab means you're doubling it, right? When you double something, what would you do? You multiply by 2. But I see where you're thinking. So I see what you did there. But you see why it's 2b and not b squared, Lovey? So your answer is 2b. Where did I get 2b from? Let's go, everybody. Let's focus. OD. I think they make a mistake with this, you know. Oh, no, it's correct. OD is 2ab. From here to here is twice the amount for AD. So that means if here is B, here is double, which is 2B. Yes, that's correct. Let's look at the other one now. OA, where's OA? OA is 2DC. Where's DC? No, this is different. What should I label DC then? Let me see who thinking. Would excellent. It would be a half of A. Small little. Everybody realize why it would be a half of A? Because what it's saying is that OA is double DC. Even look at the picture. So even if the words don't make sense to you, look at the picture. Wouldn't this be double this? And you know how they help you? They literally help you by putting this arrow here between, because this is the halfway mark, right? And you realize they put the arrow the same place. So this distance here is the same thing, even though it don't look like it. Everybody see what I'm trying to show you? Another way to look at it too is transpose. Watch this. OA is A, but I want DC. So divide by 2, divide by 2. Cancel. So that means DC is a half of A. For those who wasn't sure, everybody seeing it now? So it's like they do the opposite of what they did here. Here they make it double, but over here they make it half it instead. So everybody okay with this now? So you realize, did we even read anything? We ain't read nothing yet, you know? We ain't read nothing yet. All we doing is trying to make sure we understand our diagram, right? All right, so let's start to look for our equations. AD. AD. So let's write the equation. What would be the equation from A to D? Anybody? Using the picture? Even not kind of showing you with the arrows, you know? What is the formula for AD? Using the capital letters. What's the formula? What's the triangular law to get from A to D? Where would you go? To get your full marks, you have to show all. You can't just jump straight into it. So talk to me. What would it be? But that's correct. How did Vanny get that? Wouldn't it be AO plus OB? Which is exactly what Mia said. So if we follow along this line, it's the opposite direction. So that's going to be one negative A plus 2B. If you got it, say got it. And I need to see more people trying to send the answer even before I do it, because that's what literally going to push you to where you need to be. Yeah? And we should remember also, why did this move? This is the same thing as what? They're saying the same thing as 2B minus A. See? All right. BC. Who could come up with the formula for BC? That's a lot. Not really. But let's go. We want to go from B to C, but we can't pass this way. We gotta go all the way around. So tell me the formula for BC. What's the pathways? Mm-mm. There's no BO. There's no way to go from B to O. Follow the lines. Very good. They're gonna be BA plus what? AO. Excellent. Sorry, I don't know where I write OA. Yeah. AO. Uh-huh. Plus OD. Excellent. Tell me if you've seen it. And then the next one is what? We ain't done. Plus DC. Everybody see what's going on? So all of these here got letters. So let's go. What is going to become? BA is what? What is this small letter for BA? Negative B. Pay attention to the direction. Remember BA going in the opposite direction. Good try. Let's go. Try for this one now. Plus AO. What's AO? Negative A plus, what is OD? 2B plus, this is supposed to be DC, sorry. A half of what? A half of A. Now the rest of this A in algebra. So let's see if you could simplify it now. So that's going to be negative B minus A plus 2B plus a half of A. Let's go. Add up this for me. We're going to have to put all the B's together. Very good. So minus B plus 2B minus A plus a half of A. So what is this going to give me? This is going to give me B. If I got minus A and I add a half, the other half A going to be left back. So it's going to be what? Minus a half of A. Tell me if you've seen it. No, anybody want to hear how to do this as a trick if you're not good with fractions? Put in your calculator this, right? What is the coefficient of negative A? 1. Plus a half. So just pretend like the A is in there and put the fraction part in the calculator. So you put minus 1 plus a half, and then it's going to give you minus a half. And then you know that's your coefficient. Everybody see what I mean? Hello? That's a trick. So if you don't let the variable part confuse you. So if you struggle with the fraction part, you just put it in your calculator. All right. Look at here. If you got it, say got it. What's that I had? That wasn't that hard, and everybody realize this is not hard. I hope everybody's starting to feel a little comfortable, starting to kind of get a drift of it. All right. So they have another method. I think we got one more question. So let's go. It says state the conclusion about. No, in vectors, right? In vectors, this means something different than what it means in matrices. In matrices, these two lines mean determinant. And in vectors, these two lines mean size, like the size of the vector, right? So what's the first thing we need to know? They say, state the conclusion about these two. So before we could state a conclusion, what should we do first? We should write them next to each other. And then, very good, magnitude is another word for size, right? We need to write two of them next to each other so we could kind of get an idea of how they look next to each other. Everybody see what I'm saying? Hello? So we found AD already. Sorry. Now, when it comes to conclusion, what is the only options you could say about two vectors is either they are what? Parallel or collinear, right? Or not parallel. So to be honest, ain't like you got a million options. So you should already know your answer gonna either say it's parallel or it's gonna say it's not parallel. Okay? So let's take a look at what we have here. Now, watch what's gonna happen. They say AD is 2B minus A. We found this already. And this is what we found here. Now, be honest. Let's pretend like we ain't have this part here. Would you be able to tell that one is a multiple of the next? Be honest. Is it obvious that one is a multiple of the next? How would you go about determining that? Because remember, you ain't gonna got this part here. So pretend it's not here. You have these two answers. So that's the first question. Can anybody look at these here and see if they're parallel or not? Yes or no? Let's go. Because the first thing, there's a clue. They ain't got a clue. How do I get from B to 2B? What would I have to multiply by? A multiply by 2, that in a hint of what you should do. And then you should know if you multiply this by 2, this going to cancel out and give you 1. So when you do that, you realize K is actually equal to what? K is actually equal to 2. Because if you had multiplied this, and let's say you had end up with another number here, then you would have known it's not parallel. Agree or disagree? So sometimes you have to be able to look at what you have and make the right decisions or come to the right conclusions. You gotta think smart. Stop acting like everybody gotta tell you what to do. You have to learn how to interpret and figure it out. So once I multiply, I know to get from B to 2B, I gotta multiply by 2. So let me see if I multiply by 2, that this also makes it match. And when it matches, that means, oh, that is K. K is 2. If it did not match, then we know that it is what? Not parallel. So once we know that one is a multiple, I remember I spoke to you that a multiple could be a fraction. Once is a multiple of the other, it means that it is what? That it is parallel. If you got it, say got it. That's 2 past papers there, guys. How we feeling? We getting better, we feeling better, we feeling like, okay, question 10 ain't so bad. We feeling more familiar. Like, what's up, what's up, what's up? We getting there. More feedback from other people, please. Waiting. I'm not moving on until I get more. I hear from you guys. No, I am going to skip through questions because we have not done a question about simultaneous equations yet. So we're going to scroll through the questions, right? We're going to scroll through it and we're going to see if we feel comfortable. If there's some question you want me to do, we're going to do, but I am going to look specifically for our exam with simultaneous equations because that's something I need to make sure you guys know. So let's take a look at this one. This one look easy. This one was January 2024. That look easy. Find your equations using your formulas. We could do that. Here it is. We did something like this before, and when we had to find C, so everybody should be good with that. You know, you match it up, you solve to find your equations. But this last part here, how much people remember how to solve simultaneous equations using the matrix method? Yes or no? Very good. Very good, guys. Very good. So that means I don't need to do this from scratch. We could just follow along this example then, guys. We could do that. All right, so let's do that. So the first thing you need to do is this is the thing that you need to remember. This formula here, you need to remember. You have to memorize this because this is what tells you how to find your X and your Y. So what you should know is that A is your coefficients, right? So this is a matrix with all the coefficients. So one number should be in A. Look at here. So that should be 5, -2, right? 2 and 3. So let's make sure we do this step by step. Y, because every time I ask you a question, you're gonna put Y for yes and N for no. So everybody understand how to find A? quickly, YRN. So we pull it from the equation. Good. Then X is our variable. So that's easy. X is just X and Y. And you write it like this, X and Y. Pretty straightforward. And B is obviously your answer. So that's 44 and 10. So this is how we find the three elements that you need to use to solve this. Now, we are trying to find X, which is our variable. So we have to transpose. So when we move A over, it becomes the opposite. So it's like dividing by A is the same thing as multiplying by A inverse. So you see, this part of the formula is actually the most important because this is what we're going to need to actually work out to find X and Y, which is X matrix. So what are the two things we got to find? We got to find A inverse because do we have A inverse? No, we only have one, A. So we're going to come to the side and we're going to find A inverse. We know the formula, 1 over the determinant of A times A adjoint. So we go ahead and we find the determinant. The determinant is 19. And we found the adjoint. How do we find the adjoint? We switch A and D. So those two switch. And we multiply these two by -1. So this one was negative. It became positive. This one was positive. It became negative. So I'm going to pause right here to make sure everybody understand how we reach here. Yes or no, or YRN, talk to me. So everybody, you're letting me know that you understand how we got our inverse value. No, usually you would apply this to this, but we don't do that because it's harder to work with fractions. So we leave it as two separate entities for now. So that means the last thing we're gonna apply is this 19 divided by 19 because if we do that now, like I said, who trying to multiply by 3 over 19 to create stress? So A inverse would be two components. So we go back to the formula. What's the formula? X is equal to A inverse, which we just found, these two pieces here, times B, and we had B before. So now all we gotta do is, oh, so should I finish it? Finish it, guys? All right, so there we go. So I'm going to bring back down 1 over 19 because we ain't using it yet, right? Then, so let's go. We have 2 rows and 1 column. So you know you got your top and your bottom and your 1 column. So tell me the combinations. You're going to tell me the combinations. And you should see that we could multiply middle numbers match. So we can get 2 by 1. That's why we got 2 by 1. So tell me the first combination, please. 3 times. Excellent. 44 plus. Excellent. Very good. Bottom combination. -2 times 44 plus 5 times 10. So we're going to get X and Y is equal to 1 over 19. So what's the answer for up here? What's 3 times 44? Somebody calculator. Thank you. 132 plus 20. And this would be -88 plus 50. I kind of getting a little tired, so just back check for me, please. So X and Y is equal to, somebody give me the final sums. This would be what, 155, 152, 152, and the bottom would be what, 38, -38. Now that we have a single number, what can we apply now? We now apply the 19. So XY, you realize I keep bringing this down and I keep bringing this down. Now we could apply it So 152 over 19 and negative 38 over 19. So somebody calculator, divide those two for me. Tell me what we get. What's the first answer? 152 divided by 19 as well. 8, good. And then the bottom would be what's the bottom? Negative 2. So how do I write my final answer? Because this is not my final answer. My final answer is therefore x is equal to what? 8 and y is equal to negative 2. If you got it, say got it. Yeah, see how much work in this is? That's why I wanted to make sure we do it. Because this is the only other thing that would come that is a lot of work, a lot of math. You see, 4 maths is a big deal in maths, eh? Because there is literally break down every little thing. Okay? So I think we literally have covered every possible type question. You know what ain't come? Matrix transformation, so we got to do that. So I gonna skip through until I find a matrix transformation question. I need to know how much people, I think my class, we have not gone into it in depth, so I'm gonna give you guys some quick notes. So let me give you guys some quick notes quickly. Once you got your pen and your book and you're ready, say ready. I just need to give I some quick summary notes here. Nothing hard. Everybody from my class, page, if you got your summary notebook with your formula notebook that I gave you, the blue book, go to hold on. Go to page 84. Go to page 84. I think that page got scrambled for your notes, so I'm kind of going to give you this. You can write everything I'm about to give you, write it on that page, 84 and 85. For everybody else, you can copy this down in your regular notebooks. All right, so listen to me. Matrix transformation, right? This is where I'm going to go back to the exam with the formulas that you need to know. Hold on. You see this here? This is very important. I think everybody should have done general transformations. I think this is what I'm going to focus on in class this week with my class. So we're going to do both transformations. We're going to do the graph transformations, which comes in question 3, and we're going to do matrix transformations. All right, so translation is when you have an object and it moves on the graph by either sliding right or left, or goes up or down, right? And it is dictated by a single column matrix where the top number is the X and the bottom number is the Y, right? So this is translation I'm representing here. If X is positive, what type of movement is that? That's a right movement. If X is negative, that's a left slide. Then you have a Y movement. If Y is positive, that is a up. If Y is negative, that's a down. Everybody with me? So we should know that the original figure is called the object. So here, as you see, the object, and then the translation is what is done to the object, and the answer you get is called the image. So this formula is the translation formula. Once you finish copy down that, say got it, please. So that means anytime you're translating something, you're moving the object up and down, left or right, it's an addition formula. However, the other 3 transformations, which would include reflection, rotation, and enlargement, they are multiplication. You have to multiply the matrices. So the image is equal to MP. Also, this is very important, guys. The transformation always come in front of the object. So you would never see this. If you multiply PM, that's going to be wrong. Where must you put a transformation? The transformation must come where? In front. Everybody with me? There's also something called a double transformation. So for example, let's say I do two transformations on an object P. First, I did a T and then I did a Q. Which option is the correct answer? Is the answer, remember this is first and this is second. Is the answer Q, T, P, right? T, Q, P, or P, T, Q? Which one is the correct formula? Remember, P is the object. Everybody gotta choose. Which one is the right order that you multiply this in? That means none of you listening to me. That's actually the one that's the most wrong. Why? Because the transformations, ladies and gentlemen, must be in front of the object. So this is the only one that's literally completely wrong because P should never be in the front. P has to be in the back. So the truth is between these two. I can't believe I choose the So which one between the two now? Let's go. Excellent job, everybody. With those who said it, the answer is this one. Very good. Because the one that is done first is closest to the P. T was done first. P was transformed by T first. And then after came the Q. That's why it's the furthest away from the P. If you got it, you got it. So this is something that you should know. You could work this out in two ways. The first way that you could work it out is find TP first. And when you get your answer, then you find QTP because you know you got one matrix for this, right? Or you could multiply Q. You could multiply Q and T and then get one transformation and then multiply it by P. Everybody see the two options that you could get? You can multiply TP first, and then wherever you get, you multiply Q after. Or you can multiply the two transformations, get one mega transformation, and then multiply by P. Which one you think you would prefer? It's the same amount of work, to be honest, huh? It's still multiplying twice. But which one you would lean toward? Like, I want to know. I know what I would do, but I want to know what you would do. The first one or the second one? Hello? Anybody out there? Y'all hearing me? Okay. Okay, that's cool. So just make sure you know what strategy you would use. So let's go back to the point I was making before I give you the quick notes. So like I said, addition only happens between translation, and this is the formula. The image is equal to the object plus the translation, right? And you should know that in addition, it doesn't matter who comes first because T plus P is equal to P plus T. What rule is that? It's that with a C. What rule tells us that it doesn't matter what order you add something in? The C law. Commutative. Everybody got a commutative law? All right. All right, so let's go back to what I trying to show you. So everybody copying this down. In exam, they're gonna give you some matrices and you got to know what they mean. So watch this. Everybody should know this matrix because I gave my class. Everybody should know what this matrix is called. What is matrix called? It start with a I. Excellent, Gav. This is the identity matrix. This means if you take this and you have to memorize it, look at the leading diagonal and everybody else is zero. So before everybody I start, let me know if you're locked in. If you're locked in, say locked in, and I'm not starting until I feel like everybody who here paying attention here so I could know who here and who not here for a reason. So if you're here, say locked in and I'm looking. Because being signed into class is different from being literally engaged and focused and paying attention. So thank you guys for responding so I know who is here with me and paying attention, right? All right, so let's go. So this identity matrix, just like what is the identity for multiplication? One is the identity for multiplication because anything times one would give you back the same number, right? So if you multiply any matrix, so if I had A, B, C, D, and I times it, you know what I'm going to get? I'm going to get back the same thing, A, B, C, D. So make sure you got it because this is our foundation. Hello? Everybody with me? What do we know about the top numbers? What the top numbers is represent again? The top numbers don't represent the X. And then the bottom numbers is usually represent the Y. The Y. Always remember that. So look at this. When we do transformations, the main focus usually is between these ones. When you get a matrix like this, it's usually either a rotation or a reflection. And I'm going to teach you how to know the difference between all of them. So we're starting off here. If you multiply any matrix with this, it's going to be called a rotation, a 360 rotation. So let's say I have this object here. Because it's going to end back up in the same position, right? What angle is that? That in 360. Everybody with me? But before I even get there, let me explain something to those who may not have learned this before. If I rotate from here to here, anybody could tell me what angle is that? How do I go from one quadrant to the next quadrant? That's a certain amount of degrees. How much degrees is that? Excellent job, class, 90 degrees, right? So that's 90 degrees from one to here. So if it goes over here, what angle is that? Excellent, 180. If it goes over here, what angle is that? 270, because you add another 90 degrees. Excellent. So that means if you go all the way back around, that would give me what? The 360, right? Everybody with me? And understand the angles, how the angles work? We almost finished, but this is just really important and I don't want to end class unless we do this, okay? Now, another thing is that you need to know what direction. This direction is anti-clockwise, and this direction is what? Clockwise, right? So we always go anti-clockwise first. In transformations, anti-clockwise is the main movement. So back to what I was saying now. If I do a rotation and I end up in the same position, that means that this matrix here describes a rotation, because they're going to ask you to describe it, that is anti-clockwise. And what's the angle? 360 degrees, and it's about the origin. This is the rotation point at the origin. Copy that down for me, please. So we're going to do a quick example. If I had matrix If I had 0.43, this gonna map on to 43. It ain't gonna move. It's gonna stay in the same position. Once you finish copying on that, like, sit done. Those in my class, you have it in the booklet already. I think it's 1, 2, 3, 4. Just draw the picture next to it because I think that's all you got to do, draw the picture. I'm just waiting for more people to say if they finish or not. All right, everybody okay with this? No, this is our home. This is our mother. That means everybody that comes after is an origination from this. This is the original. The identity is the original. Now check this out, right? Check this out. Suppose I give you this. All right, ready? Suppose I give you this. What you realize is the difference between this and this. The X and Y ain't switch. So what you think gonna happen to the number? So if you see a number was 43, what you think that is do to the number? It is make it what? In 3, 4. You have to make sure you understand that that's what this means. This is what this gonna do to this number. Everybody see what I mean? Because nothing ain't turned to negative, it's still positive, but it just switch the X and the Y. Yeah? This, and I'm gonna sketch a graph to also show you how to know what it is. So let's look at this. If I, all right, ready? If I was here, so let's say that's 3, 4, 4, 3, and then this is 3, 4. You realize I in the same quadrant? Do you know that this is a reflection in this line? And I taught how it is the name of this line. This is your Y is equal X line. So this is a reflection in the Y is equal to X line. You gotta memorize this. Even if you draw it and when you draw, you realize, oh, it's staying the same quadrant. It just switch numbers. That's the line. That's the transformation here. Anytime you see this matrix, that's what this does do to any numbers. It'll just switch the X and the Y. So make sure you draw that for me. And when you finish, say done. So this is 2. This was 1. All right. Now, I got another one to this, but I'm going to skip that one and come back to it, right? Because I want to show you something else. So we're going to move on to 4 and come back to 3. So 4, I want to see if y'all are with me still. Check this one out now. 4 is this. 0, -1, 1, 0. So let me see if anybody could guess what's going to happen to the numbers. What's going to happen to the numbers? Two things happening to the numbers if you're paying attention. There was a switch because in the original is this. You should know the original is that. So if it's not that, it's switch. And somebody is made negative. Who is made negative? Which one of the numbers are negative now? Yeah, but what number it represents? Is it the X or the Y? Because both of them is 1. And I told you. Gav say X. Is that true? Yeah, because X is at the top, so X is now negative. So let's go. What gonna be the new matrix then? This gonna become what? 3, and this gonna become 4. And where should I put a negative sign? Who the negative sign should go by? Excellent. Tell me if you see what's going on, everybody. Everybody see what's going on? Everybody see what I'm trying to show you? How do you know how to describe it? You sketch a little graph. So let's sketch a little graph there. Quick, 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 quick. So first, where we start off in the positive part over here. But then where we end up? We end up over here. So this is what we call, does this look like it's equal? It's not equal, so it can't be a reflection. Everybody see that? If there's nothing that makes it look like a balance, because remember everything is from the origin. Everybody see what I'm saying? Over here, this didn't look balanced. So it was easy for us to see that it's some kind of reflection going on, right? Here, does this look balanced? No, it does not. So that means anytime you see this happening, it's a rotation. It's a rotation at the origin. Is it clockwise or anti-clockwise, everybody? Let me see who really excellent is anti-clockwise. And what angle? If you're going from here to here, what angle is that? Excellent, 90 degrees. So that's that. When you finish copying on that, tell me. We're going to do 5. I'm just going to give you the rest of them. And I want to see if anybody thinking. So look at this one now. Watch this one now. Let me see if anybody thinking. What's going to happen to the numbers? So let me see if anybody could guess what's going to happen to the numbers. What's the new numbers? So tell me what numbers I should put in the bracket here. How is this going to affect it? You sure you ain't changed something? You ain't changed something? Because look, the two numbers ain't switch. Remember, the original should look like what? The original look like this. Is it that, or is the switch version? So what should happen to the numbers? The first thing that gonna happen to the numbers is that they're gonna do what? And switch positions because these switch from the original. So it's gonna become 3, 4, but somebody gonna be negative now. Excellent. Who's gonna be negative? The 4 is going to be negative because the Y is negative in this case. Should I stop or everybody at least copying down and following? Hello? Okay. Once at least a few people following, that's all I need to know. Because to be honest, whoever it helps, right, guys? So let's see what type of movement this is. Anybody want to guess what type of movement this is? So let's see where we move from. Where were we first? We were here. And where we end up? What quadrant we end up in? We end up in quadrant 4. But we ain't exactly the same place because this was 4. So it's like here. Sorry. It's like here. Because they ain't line up, we know is it a rotation or a reflection? And you should realize the similarity between these two. So it's going to be a rotation. What direction? Where we going again? Ain't always anti-clockwise. But what is the angle for this one? What angle did I rotate? It's not 90. Excellent. 270 at the what? The origin. Let me just make sure y'all see. Yeah? I got two more. I got two more. So can we finish strong? There is three more. So let's do this one now. 6. All right. You're gonna tell me what you think this gonna do. So this one now is 0, -1, -1, 0. What is this going to do to the numbers? Let me see if I really focus in. So we're going to start off with 4, 3. Who could tell me what's going to happen to the numbers? I in it with you guys. Let's go. We got this. What's going to happen to the numbers? Pay attention. Look at the pattern. They're going to switch. Excellent. Good. So it's going to be 3 and 4. Excellent. But both of them going to be negative. Everybody see that? So it's going to be -3 and -4. Very good. So now let's draw the map and see if we could see what type of, and we already know what going to happen to it. Everybody know what type of transformation this obviously going to be, right? What type of transformation this going to be? It obviously is a rotation, right? So now we just got to decide what angle is the rotation based on where it drop. And we already know that it is anti-clockwise, right? So let's see. We were in the positive, we was in quadrant 1, and we end up in what quadrant? Exactly. We end up in quadrant 3. So what angle is that? So let's break it down. So we know it's a rotation. We know it's anti-clockwise. Excellent. Oh my God, I could cry. Very good, guys. 180. And what else I must state? I must state the center of rotation. What's the center of rotation? At the origin. Very good, guys. Excellent. 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 Very good. So we got two more now. 7. And you're going to see this one is a little different. Just a heads up. So don't assume it's the same thing. So let's look at this one now. Check this one out now. 1, 0, 0, -1. Let me see who can pick up on this one here. What gonna happen to the numbers? Is there a switch for this? Let me zoom out so you could see the original. Is there a switch? Remember the original, where the original is here. This is the original. Is there a switch? Let's go, peoples. There's no switch. You realize it looked just like the identity, but somebody get made negative. Exactly. Very good. So what would be my number? It would be what? 4, -3. Boom. Boom. No, this is a clue. Because the numbers are the same, but one gone negative. Let's draw the map. Let's see if we understand what movement this is. So watch this here now. This here was here. The number, it stay at the same Y. It stay at the same X. That means this is we X it. The X ain't change. But instead of going up, where did it go? It go down. What does it look like to you? It the same exactly. Very good. This is a reflection wheel. What is it being reflected in? What's the mirror line? They say in the X-axis and reflected in the X-axis. So the reflection in the X-axis, anybody could tell me the equation for the X-axis again? What's the equation for the X-axis? Y is equal to 0. Guess what? That's it. And the last one, obviously, because if we're going to do the reflection in the X-axis, we got to do the reflection in the, what's the last one? Anybody want to guess how that one gonna look? How that one gonna look? It definitely gonna be the same numbers, but who gonna be negative now? Instead of the Y being negative, who gonna be negative? The X gonna be negative. So this is what gonna happen to our numbers. 4, 3 gonna become more -4, 3. So we're gonna draw that. So where did we start off? We start off here. but instead of positive x, it gone over to the negative. Same distance though. You realize it stay on the tree, the same y. Everybody see that? So this is what we call a reflection. And how do we describe a reflection? We must take the mirror line in the y-axis. Sorry. In the y-axis. And what's the formula for the y-axis? X is equal to 0. That's it. I know we push a little bit, but I'm just glad that we were able to do this. I really wanted to make sure y'all have this. Everybody with me? Even if you don't remember all of it, once you kind of remember the trick I show you, what's the trick I show you? Remember, what's the main important thing? What's the main one you must memorize? You must memorize what? The identity. Oh yeah, let me do tree. What was tree again? Thank you so much. Tree is the opposite here. Tree is this one. Excellent observation, Novi, where both of them is negative. This one is, so let me zoom in here. Everybody realize what's gonna happen for this one? What's gonna happen for this one is a switch and a double negative. So 4, 3 gonna turn into a -3, -4. And what's gonna happen with the graph? Let's look. If you were up here and you end up here, you're gonna end up here. Yeah. That is a reflection in the line y is equal to -x. You see how the one above, look at it, look at the difference between the two guys. Same thing, but one is positive, it stayed in the positive, and one gone over in the negative. So this is y equal positive x, and on the other side is y equal -x. Thank you. Should I zoom out? Ladies and gentlemen, for those people who are not in my class, because my class, we're going to go through this tomorrow. We're going to do Monday and Tuesday. We're going to go through these questions and practice it, especially the transformation part. So all the other students, make sure your teachers give you past paper practice where you get to do it on your own and they kind of help you to go through all of this, okay? All right, so that's it for tonight. I'm gonna download this video and try to send it first thing in the morning for you guys to have to go over. But how was class today? It's a lot we did, but was it helpful? I feel like we did a lot. I feel like we took question 10 to another level. So I hope that everybody feel a lot more clearer, in a better position. And don't forget to do your studying and practicing on your own, okay? Have a great evening. See you guys next week. Bye.